Okay, today we're going to be talking about chapter 13, which is all about glaciers. You can see this picture is from the Bering Glacier that is in Alaska. It is the longest glacier in North America. So just a little background. Our ice age happened between about 2.6 million to 10,000 years ago. What we consider to be the Holocene maximum was about 6,000 years ago. The medieval warming period was about 1,000 to 1,300 AD, and the Little Ice Age was 1,500 to mid-1800s. So exactly what is a glacier? Well, a glacier is a moving body of ice on land. It will flow downslope or outward from areas of accumulation. About 10% of the Earth's surface is presently covered by glaciers. In a lot of places, they're a very important source of water. We have different types of glaciers. This first picture shows what's known as a valley glacier. So valley glaciers are going to be those that are confined to mountain valleys. They are going to flow from high elevations to low elevations. Sometimes you might see them also referred to as alpine glaciers or mountain glaciers. If they flow into the ocean, they would be known as a tidewater glacier. Now these can be very big. I say several kilometers across, tens of kilometers long, and they can be several hundred meters thick. This shows a picture of a valley glacier in Alaska, and you can see how the glacier is moving from the high elevations down to the lower elevations along the mountain valleys. Our second type of glacier are our bigger glaciers. Those are our continental glaciers. They cover at least about 50,000 square kilometers. We also refer to those as ice sheets, and a continental glacier ice sheet is not going to be confined. It can spread out. So it's going to flow outward in all directions from the central part. 3,000 meters thick in Greenland, in Antarctica. Sometimes what you're seeing in this picture right here is what's known as a ice cap. And that's basically a dome-shaped mass of glacial ice. It's similar to, but it's smaller than a continental glacier. So it's going to be less than 50,000 square kilometers. Now, glaciation is going to be a term that refers to all aspects of glaciers. It's going to refer to the origin, the expansion, the retreat, and their impact on the surface of the Earth. We've talked about the hydrologic cycle. What about glaciers in regards to the hydrologic cycle? Well, glaciers can flow into the water. When they flow into the ocean, they're going to melt, or they're going to do what's known as calving. Calving is when they break off. If you have a chance, please look at the YouTube video that I've given you the link. It shows the process of glaciers actually breaking off and falling into the water. So typically at our low latitudes, or areas that are kind of remote from the oceans, the glaciers are going to flow to our lower elevations, and then they're going to melt into streams or groundwaters. We have sublimation. Well, glaciers can also lose water by sublimation, and that would be when your ice changes to water vapor. So what actually is glacial ice? Okay, if you follow along in this picture on the right, glacial ice is actually a type of metamorphic rock, and I know that might seem surprising. It's a rock that's easily deformed. It consists of about 90% solids and 10% air. So what happens when we have water in that solid state within a glacier, you can see at the beginning of this diagram, it's going to form as your snow starts to partially melt. That snow is going to refreeze and it's going to compact so that it's transformed first into what we call firn, which is this right here, and then it goes into your glacial ice. So in order to have a glacier forming, I need to have more snowfall than it's going to melt in the warm season. So I'm looking for that net accumulation of snow. Now, anytime I look at the fresh snowfall, it is a mixture of mostly air-filled pores and about 20% solid. It will start to compact as it accumulates, partially thaws and partially refreezes. So when that accumulating snow and ice reach what we call a critical thickness, and that thickness is about 40 meters, the stress on your ice at depth is going to be strong enough to induce movement. It can move in one of two ways. It could move by plastic flow, in which your stress and strain are going to induce that permanent deformation and movement. So that movement, that flow, is taking place in response to pressure, and it causes deformation without fracturing. Or we could have what's called basal slip, and that's when that glacier slides over the underlying surface. It's only occurring occasionally compared to the continuous movement of your plastic flow. So what's going to happen with your basal slip is your liquid water is actually going to aid in that basal slip, because that liquid water is going to reduce the friction between the glacier and the surface that it's moving over. So we could have what's known as a crevasse. And a crevasse is going to happen when the upper 40 meters behaves like a solid and it's going to fracture. It's going to open where the brittle part of your glacier is stretched as it moves over a steep surface. So you can see in this first picture, picture A, how the crevasses open up where that brittle part of your glacier is stretched. Notice the tension that you're seeing here, where it's being pulled apart. This picture B is showing some crevasses on a glacier that's in Alaska. Okay, this is going to end part 1 of chapter 13.